Macroeconomics review for the rules for the money multiplier. Now, first thing, this sheet you had access to last semester is your best friend with the rules for the money multiplier. It summarizes everything I'm about to go through today. It's still on Canvas under the macro notes, or I still have copies of it if you want to come and grab one for me. It'll really help you study. So with this is a bank's T-chart. That's how we set up for the rules of the money multiplier. So a bank's T-chart means it looks at a bank's assets and a bank's liabilities. Liabilities are their debts, assets are the things they have in their benefits. And the first thing we're going to talk about is a demand deposit. A demand deposit is the money that people put into the banks. It's a liability for the bank because the bank has to pay them back whenever they want to use that money to pay for things. In the assets column, we have the required reserves. This is the percentage they have to keep in the vaults at all times. It was one of the tools of monetary policy. It's also what limits the money multiplier, and excess reserves. This is the amount of money that banks can loan out. And we know banks collect interest, and that's their profit from loaning out money from their excess reserves. And that illustrates an important AP concept. Interest is the cost, or interest is the opportunity cost of holding money, because for a bank, if they're holding on to their money instead of loaning it out, they're not collecting interest, they're not making money. So the typical AP question will look at how when interest rates are higher, the opportunity cost of holding money goes up because banks aren't collecting their profit. The first type of the three types of problems we're going to look at for the money multiplier are demand deposits. These are just consumers and producers putting their money in the bank. They put it there fully expecting the bank can pay them back on demand, which are why these demand deposits are a liability for the bank, because they have to pay the people who put their money in their back whenever they ask for it. And under the assets, we look at that money and look at how much of that money they have to hold in the vault and how much they can loan out. So let's say that I make $50,000 a year. And I have direct deposit, so all that money directly goes into the bank. I don't even ever touch it. So it immediately goes into the bank. And the required reserve is 10% for this bank. Now, honestly, they're only going to give you required reserves where you can do the money multiplier math in your head. So the couple scenarios you'll see are 10%, 20%, 25%, and 50%. Because most people can do those money multiplier fractions in their head without a calculator. So in this case, the reserve requirement is 10%. So by law, this bank has to hold 5,000 of the 50,000 just sitting there idly in the bank, which means though that they can loan out 45,000 of my initial deposit. So they're gonna loan out most of it. And as they loan it out, this process of giving out loans, the minute they give out a loan of that money to someone else and that other person puts it into the bank, is what increases the money supply, because that shows money creation because the money's in more than one place at once. So to calculate how much my deposit can increase the money supply by, I'm gonna look at this thing called the money multiplier formula. And the formula for that is 1 over the required reserve, and in this case it's 10%, so it'd be 1 over 0.1 or 10. And let's look at really quickly the other examples this could be. So if you're bad at math like me, you can just memorize them. So we already said this was 10. If it was 20%, it'd be 1 over 0.2 or 5. If it's 25%, 1 over 0.25 or 4, and if it's 50%, 1 over 0.5, which equals 2. So these would be the different multipliers we would see. And we always times the money multiplier by the excess reserve. So in this scenario, I would times the 45,000 by 10, the money multiplier, and that would give me my new demand deposits. So new demand deposits are loans. I always summarize this by loans, and that'll be important because if on an AP question they ever ask what's the maximum total change in loans, that's all the loans that went from bank to bank to bank to bank added up. That is by definition this, the new demand deposits. So this would be your answer for the maximum change in loans. The other possible questions they might ask you over this demand deposit problem: did the money supply initially change? This is important. When I put my money in the bank, it didn't actually create any money. It didn't change M1 money. So no, the money supply did not initially change. What changed is now that money is in the banking system. So that money is in the banking system, but it didn't actually create money. But from there, the bank can loan out the excess reserves. second question, which goes with that, how much can this bank initially loan out? That is always ER, the excess reserve. So whatever it is, no matter what type of money multiplier problem it is, ER will always be how much a bank can loan out. The next question is, how much could the money supply potentially increase by because of my deposit? And my answer in a demand deposit problem is NDD. Not this, because this wasn't created, but this was created by giving out loans. So the total potential change in the money supply is $450,000, which is a lot just for me putting my money, which is what most people do with direct deposit all the time. And then the final question with the demand deposit problem was how much money went through the banking system, what's the total change in reserves, what's the total change in demand deposits, all asking the same thing. And for every type of problem, it's just DD plus NDD, or in this case, $500,000 in total went through the banking system. And that's how you do a demand deposit problem. So let's look at a similar scenario, but with this thing called a public bond. So we're going to do the bonds now. I'm still going to use my T-chart, and some of the things are going to look really similar, but public bonds are a different type of money multiplier problem. Public bonds are bonds from the Federal Reserve to the public sector. By that, I'm talking about open market operations, government securities, or it may say the Federal Reserve buys bonds from the public. All three of these things look at the Federal Reserve buying bonds from the government. And what we assume the government does, just like consumers and producers do, is put that money into the bank. So everyone puts their money into the bank. So let's, to keep the math kind of similar, say it's a $50 million bond. The Federal Reserve buys a $50 million bond from the government. So it's a public bond, and the trick is public bonds always start in demand deposits. So that 50 would start here, and I'm going to go through the same process. They hold on to 10% or 5. They have 45 million that they can loan out, times by the money multiplier of 10 still from over here. The new demand deposits is 450 million. So then let's look at the types of questions there are with public bonds. The first question, and probably the most important question, is what immediately happened to the money supply? Because this is the only scenario that does this. Public bonds instantly create money. Because when the Federal Reserve buys that 50 million in public bonds from the government, they're immediately increasing the money supply by 50 million, which is why it's the most often used tool of monetary policy, because it instantly does expansionary monetary policy. It instantly increases the money supply. So this instantly increases M1 by $50 million. But then it also goes through the process. So they can also loan out 45 million, so the initial change in loans, the max amount they can loan out is 45 million, and then 450 million is created through the money multiplier. But the wording on the questions of how much the money supply can change by is actually a different answer, because the maximum amount the money supply can change by will now be the 50 million created from the initial purchase of the bond, plus the 450 created through the money multiplier effect. So the maximum potential change in the money supply is now $500 million. Then when we look at the total change in the banking system, total change in demand deposits, total change in checkable deposits, total change in reserves, that would still be like demand deposits, DD plus NDD. So in this scenario, 500 million went through the banking system. So yeah, the answer for the total change in the money supply and the total change in demand deposits was the same in a public bond. And then finally, the maximum change in just loans for this public bond is 450 million. So whenever asked about the maximum change in loans, no matter what, it's just NDD. So this is a public bond. The biggest distinction, it instantly creates money. It's the only one that does. And then the final scenario that we have is a private bond. And private bonds, although similar sounding, are very different than public bonds. So private bonds are bonds that were already in existence in a bank's excess reserves. And on the review sheet, I said they're bonds between banks. Usually what you'll see is it's a bond from the Federal Reserve to a commercial bank. Different wordings: the Federal Reserve purchases a private bond from a commercial bank, the Federal Reserve purchases government securities from a commercial bank. It's still bank-to-bank bonds. Don't let that government word mislead you. It's still the Fed is buying it from the bond from the bank. So because of this, because these are bonds that are already sitting in a bank's excess reserves, this money will go from being idle, unused, to now they can use that money in their excess reserves. So because of this, a private bond starts in a bank's excess reserves, meaning that nothing happened in demand deposits, nothing happened in required reserves, and there was no immediate impact on the money supply because that money already existed in the excess reserves. Then from there, again, we times it by the money multiplier, and let's go through the potential answers. So the first question, did the money supply initially change? No, we already said that. Also, demand deposits and required reserves did not change. Now, how much can this bank initially lend out is $50 million. What's the maximum change in loans? Still just NDD, but now it's $500 million. But then the last two answers are the same. What's the potential increase in the money supply? $500 million. What is the maximum total change in the banking system, which is DD plus NDD? There's just no DD to add to it, so still $500 million. So if you mix up public and private, you could still get part of the question right because the total change in the money supply and the total change in the banking system are the same with private and public bonds. The only difference is a public bond starts here in DD and a private bond starts here in ER. And those are all of the scenarios with the money multiplier.